Okay, we're going to do a couple of examples here. So this says determine the critical values of the following functions. Then find any extreme values of the functions and where they occur. Okay, so remember critical values are points in the domain of the function. So we'll say x values in the domain of your function f of x, where f prime of x is equal to 0 or f prime of x is undefined. Now, it's important to remember this part that the value has to be in the domain. So if you already have something that's not in the domain of f, then it can't be a critical value, even if it makes one of the other two statements true. Okay, so here we have our function that we're going to find the critical values of. So f of x is equal to x squared plus 7x minus 1. Now the domain of that function is negative infinity to infinity, all real numbers. So if we find any place where this is 0, the derivative is 0 or undefined, it will be a critical value. So f prime of x is equal to 2x plus 7. Okay, so there's nowhere where that's undefined, so we just need to find where is that equal to 0. So we get 2x equals negative 7, x equals negative 7 halves. Now, that gives you where we have a max or a min, but we don't know what that value is. To get the max or the min, we need to plug the value into our original function. So we want f of negative 7 halves. And I'll rely on my calculator. So we want negative 7 halves squared plus 7 times negative 7 halves minus 1. Okay, so our function value is negative 53 over 4. Now, to know whether this is a min or a max, let's just think about what we know about this function. So from previous classes, you should know that x squared is going to give you a parabola. And with the a value, the coefficient of the x squared being positive, being 1 in this case, we know it's going to be facing up. So what this actually gives you is your minimum value. So in pre-calc, you might have learned the vertex formula. This basically gets the vertex for you. So we found we have an absolute, it's also a local, but an absolute minimum of negative 53 over 4 at x equals negative 7 halves. Okay, and the parabola is going off to infinity in both directions, so we don't have any local maxes here or an absolute max. Okay, next we have f of x equals 3 over x squared. Now, we know the domain of this function is all real numbers except for 0. So that would be negative infinity to 0, union 0 to infinity. So we would never have a critical value at 0 because we actually have an asymptote there. But we'll see what else is happening. So we're going to take the derivative. Now first I'm just going to rewrite f of x as 3 times x to the negative 2. So f prime of x is equal to negative 6x to the negative 3, which would be negative 6 over x cubed. Now, this is undefined at x equals 0, right? Because you'd be dividing by 0. But that's not a critical value because 0 wasn't in our original domain. So, we would want to find out, is this ever equal to 0? But if we tried to multiply both sides by the denominator, by x cubed, we'd get negative 6 equal to 0. So this is also never 0. So this function, 3 over x squared, has no critical points and no extreme values. Okay, and if you look at the graph, okay, it's going off to, we've got this asymptote where it's going off to infinity, and our horizontal asymptote is at y equals 0, and so it's never actually hitting that minimum value. Okay, and then our last one here, we have f of x equals the square root of 3x minus x squared. So first, let's talk a little bit about what the domain of this function is. So to find the domain of a radical function, we need to take the radicand and set it greater than or equal to 0. Now I'll pull out an x. So when you solve something like this, you make your sign diagram. So a 0 and 3. If we plug something like 1 in, we would have 2, which is greater than 0. If we plug in -1, we'd have -3 minus 1 be negative. And we plug something like 4 in, we'd have 12 minus 16, that would be negative. So our domain of our function here is from 0 to 3. So the only place where we could have critical values would be from 0 to 3. Now, before we take our derivative, I want to rewrite f of x. So I'm going to rewrite this as 3x minus x squared to the 1/2. So when we take our derivative, we'll end up using the chain rule here. We're going to have 1/2 3x minus x squared to the -1/2 times 3 minus 2x. Now, this is one of those cases where rewriting this in the proper form, or the most simplified form, is helpful. So we're going to have 1 over 2. The -1/2 makes the square root of 3x minus x squared. And then we have 3 minus 2x. Now, we need to know where is this undefined and where is it 0. Now, it's going to be undefined when the denominator equals 0. Now, we've already, 2 is never going to be 0. We've solved when this will be 0, and it'll be 0 at our two endpoints here, 0 and 3. So it's undefined at x equals 0 and x equals 3. So those will be two critical values. Now it's 0 when the numerator equals 0. 3 minus 2x equals 0, which will give us x equals 3/2, which is also interval. So we're going to have to kind of look at 3 points. We're going to need to look at f of 0, f of 3/2, and f of 3. Now, to make this a little bit easier on ourselves, I'm going to put our f of x in our y equals. And go to the table. And I'll put this on ask so I can put in the values I want. Okay, so if I put in 0, we get 0. And we know 3 is 0 as well. So if I put in 3/2, you get 1.5. Now, since the domain is a closed interval, this is the whole part of the domain, and this is a continuous function, we actually know that these are going to be absolute maximums. And if we look at the graph from 0 to 3, okay, we get this half circle, we see that we have an absolute, so we have absolute minimums. We have 2 of them here. You can say of 0 at x equals 0 and x equals 3. And then we have an absolute maximum of 1.5 at x equals 3/2. Okay, so the absolute minimum can occur at more than one place as long as it's the same y value. Okay, so here finding the critical points, look at the domain of your function, take the derivative, find where that derivative is equal to 0 or undefined on the domain of your function.